You're up, Bill.
Yeah. Am I coming up? I think it's time. Wow. So, the young man was shy. He didn't want to come up. I encouraged him to come up, and he wouldn't stop. That's what happens.
I was 9 years old, that age, when I discovered the universe. Or rather, when the universe discovered me.
What do you mean by that?
It was my first visit to my local planetarium,
And
the Hayden Planetarium in New York City.
were you thrilled?
I was starstruck.
How many times have you said that?
No, no, you're in the big chair and the lights dim, stars come out, and I thought it was a hoax. I said, there aren't that many stars. I've seen the sky from the Bronx. There's 8 stars in the night sky. So I thought it was a beautiful hoax, but a hoax nonetheless. And it would take me a couple more years to age 11 before I had an answer to that annoying question adults always ask kids, which is what? What do you want to be when you grow up? And I'd say an astrophysicist, and that pretty much shut them up. They didn't.
Wow. I was a city boy in Montreal and looked up at the sky and couldn't see many things because of the pollution, of the light pollution. So I'm about 10 or 11, and my parents send me to a summer camp in the Laurentian Mountains. And I remember sitting on a log at night with no light pollution, looking up, and so enthralled by the sky, I fell over backwards.
You get touched by the universe.
Yeah.
There's no substitute
And
for
this
that.
young man is on his way. He's on his journey to do that.
That is clearly evident. Yes, yes.
Wow, what an experience that was with this. He's got this open mind. He's going to be something important.
Well, if you're using the word infinity at age 9, then sky's not even the limit for you.
I've got a word.
Yeah.
I've got a word for you.
Sure, what's that?
Okay, and I thought of it, and I'd read it before, and I looked it up, in to make sure that it applied to you. Abyssal.
Epistle?
Abyssal. Abyssal.
Abyssal.
Your knowledge.
I've never heard that word.
The depths of the ocean are abyssal.
Oh.
Or there's a Yiddish word meaning a little. It's abyssal, but Abyssal means huge, depth, deep.
It's of that which resembles an abyss.
It comes from abyss.
But abyss also has depth plus a dose of unknown to it, doesn't it?
And that's what I think of as you.
Oh, okay. Well,
I'm
thank
an
you.
admirer of yours. I've admired you for a long time.
You handed me one of the greatest compliments I ever got 48 hours ago. We were talking about being somewhere, on a zero-G flight, if we were ever to take one.
Yes.
And I said, I'm not entirely the right stuff for that. So who knows what'll happen to my lunch while in zero-G. And tell people what you said to me, because I was shocked. What did
I'd be proud to eat your vomit.
No!
That's how much I appreciate your abyssal. Can you talk now?
No, I got to recover from that, right.
Are you nauseated by my emotion?
Another thing, I was also 9 years old when Star Trek was in first run, but that's old enough clearly to still watch TV.
This young man is 9 years old.
That's why I said
that's
that.
your that's you in miniature.
Yeah.
It's really interesting to see these young minds. If you can open that young mind up, that's what teachers do. The great teachers are enthralled by the young minds. Like, what do you think? And not what do you want to do when you grow up, because that's too big. What's your interest now?
Yeah.
Have you seen the floor? Did you see the wood on the floor? Look at that wood. Somebody planed it. Somebody polished it. Somebody put it in a ship.
Everything is subject to inquiry.
Those photographs, you could analyze those photographs and be enthralled for the rest of your life. Did you see that penguin with the thing in his mouth?
I missed that.
he had a pebble in his
Oh,
mouth.
yeah. Move it. They're
Yeah.
stealing
no,
rocks.
No. They got the wrong idea. That penguin was getting stoned. You forgive me for these weak jokes, but I have
The
nothing
dad
else.
jokes,
Right.
and your dad, so that counts.
Right.
We okay with that.
Right. Okay. All right. I read something recently that I wanted to ask your opinion of. We're discovering the elements of life, the chemistry of life through the whole universe. There are, because of the Webb telescope. I imagine because of the Webb telescope. You'll correct me on that. But we're discovering that the elements of life, the foundation of life, not volcanic rocks and stuff, but the elements of life are everywhere in the universe. And water, huge amounts of water. How can you argue the fact that life isn't fecund all over the universe?
You can't argue against that for exactly that reason.
Exactly.
And it started, I want to go back to the 1950s. This is the decade that followed the Second World War. There was a lot of nuclear research getting declassified at the time, research from particle accelerators and all the physicists probing the atom, finding the hidden energy, exploiting that in the service of weaponry. But when you're in peacetime, you have the data. Let's look a little closer. It was not until the 1950s where we had a firm understanding of where the elements come from. I remembered being in chemistry class, well after that, asking my chemistry teacher, this is in high school, where did the elements of life come from? He said they came from Earth. And he didn't, that's, in his mind, to the chemist, that was their point of origin. But
in fact, in basic discovery, he's right.
yeah, but I was kind of, something came before the Earth, right? And so in the 1950s, we studied what happens in the centers of stars, where it's very hot and you have thermonuclear fusion. And most of the universe is hydrogen. And in the center of stars, it fuses hydrogen to helium, releasing energy. Some stars keep going. The very high mass stars go hydrogen to helium, to carbon, nitrogen, oxygen. And you see the periodic table getting filled in. And you say, all right, now what? Those stars also happen to explode, scattering that enrichment across the galaxy. And so you look at the ingredients of the universe in rank order: hydrogen, helium, carbon, oxygen, nitrogen, in that order, and other, okay? My favorite element, other. In that order. Then you say, what's life on Earth composed of? In rank order.
Okay.
And I'm going to tell you, it's hydrogen first.
Yep.
You find that in our water molecule that's half our body weight. We don't have helium because it's inert. Skip that, we get to carbon. We're carbon-based life, as any good science fiction storyteller will tell you. Next is oxygen. Next, nitrogen. Next, other.
Okay.
We are one for one the same ingredients of the universe. So by life on Earth was not taking rare ingredients and doing special things with it. It was taking the most common ingredients in the universe and being.
Okay, what's the next being what? Exactly.
It was being opportunistic.
But, right. So a number of questions occur to me. For example, being, so you got all those elements, being, and then dot, ellipse.
Optimist.
Well, what happens, you got all those things, and the secondary question is, can you have life that isn't carbon-based, like methane? Can it be methane-based? Can it be sulfurous based?
Yeah, so let me not say no to that, but let me answer it a little differently. The typical way that question gets asked is, you look at the periodic table, and chemistry weenies will remember that you have rows, but you also have columns. And every element in a column has the same configuration of its outer electrons. And that's what enables it to form molecules. Because when molecules form, It's whatever is the outer electron situation gets fulfilled with whatever another atom gives it or shares with it. So when you look vertically, right below carbon is silicon. That's why clever science fiction writers say, maybe we can take the carbon atom that it is in life and swap it out with silicon.
Can you?
And still have life.
Can you?
I don't, not on Earth.
So that attitude,
no, you can't.
What you just did means you don't know exactly, but you think it might.
So
You're not used to somebody doing this to you, are you?
You can't really do it on Earth because even though you can make the same families of molecules, their binding strengths will be different. And what made life on Earth and its boundless diversity possible is that you can make complex molecules, but those molecules can also break apart and experiment in other ways.
But its combination with carbon is
The carbon is the stickiest element on the periodic table.
Right.
It can it'll.
So it's likely that life in the universe is based on carbon.
I would say there's a stronger reason for that. There's 5 times as much carbon in the universe as there is silicon.
Perfect. So we can assume that given all the elements in the universe that we're discovering permeates the universe, and then I got to go back to where it started, it permeates the universe, that carbon-based life is more likely. If you were a gambling man, you would put a big bet on carbon-based life throughout the universe.
Yes.
Okay, we won that bet. Now,
Yes. And I say that because you always want to check your bias. All right? And that can be true in spite of the rest of the bias that permeates Hollywood, where all their aliens have a head, 2 eyes, a nose, mouth, shoulders, arms, legs, hips, and feet, and they're bipedal. It's like
But it's
we don't have anything in common with
but
those.
it's the most efficient form of locomotion.
Tell that to the centipede and the bird.
I did, and I got put down. No, but bipedal is a very efficient way of moving.
Okay. I'm just saying we are alive on Earth simultaneously with life form that cannot move at all, and they're called trees, and they're trees that'll live 1,000 years, longer than us.
Yeah, but
So I will not undervalue other life forms simply because they can't walk on 2 feet.
I'm wrong there. I'm not undervaluing. I'm just saying from the little I know, that our fingers, our arms are specialized for, yes, exactly, for that kind of thing, to conduct music and to pick our nose.
Now, if beavers were running the world, they would imagine aliens with extra sets of teeth to cut into things. We have to watch your bias as a human, and Hollywood has been awful at this. You know what the best Hollywood alien ever, I think, in my opinion? 1958 movie with Steve McQueen, The Blob. You remember The Blob? Okay.
No.
The alien was a blob. Okay? There was no eyes, nose, mouth. It was not an actor in a costume. It was just a blob. And it came to Earth in a meteorite in the Arctic. Okay? And then it was transparent, translucent initially. And what made it extra scary is you couldn't shoot it or stab it because it was just a blob. And it would ooze through the venting, the grill.
Yeah, but that's
of the air
based on
conditioning system.
slime and its intelligence to reach.
All right,
sunlight.
I'm just saying it was a created. And by the way, after it ate its first victim, for the whole rest of the movie, the blob was red. You remember that? Okay, so
I don't want to hear that shit.
I'm just saying.
I'm
just
facts
saying.
from you.
That's a life form that came from another planet.
I got you.
With no
I
DNA in
got you.
common with us.
I got you.
Maybe even not even any DNA.
I got you.
We have 20%, 25% identical genes with a banana. So if an alien comes, it should look at least as different from humans and bananas as human and bananas
we know
look
that
from each other.
Trees are giving off electrochemical signals along the mycelium.
The mycelium, yeah.
Mycelium?
Mycelium.
It's not mycelium? Is it abyssal or is it abyssal? Yes, so but electrochemical signals.
The
from
more we
trees.
study life that's not human, the more amazing it is to us in its ability to survive, to thrive, to communicate, to make decisions.
And to relate to the structure of our DNA.
Yes.
Yeah.
In fact, one of the themes that infused Jim Cameron's film Avatar
Yes.
was, do you remember those native peoples could communicate with nature?
Yes.
They had like a USB ponytail, that would plug into the plants, and so that was a version of a mycelium,
Right.
but involved
And we don't,
animal creatures.
But we don't need that to communicate with non-human life. We communicate all the time. I'm thinking about horses and dogs and other life forms. The orcas. We don't know the subtlety of the higher animals, the elephants, the orcas, the bonobos. We don't know.
I think they're all smarter than we have ever given them credit for being.
Absolutely. And
Have you seen that YouTube video there's a magpie bird? Magpie is a black and white bird, and there's a little sort of water bottle sitting in the middle of a park, and it's filled up to the top with water, and it puts its beak in, sucks out the water, but then the water level gets below its beak, and it can't suck any water out anymore. So it wanders over to the side, gets a pebble, drops the pebble into the water bottle, raising the water level, and it keeps drinking, and it does this 3 or 4 times.
Well, we know
that is a Bernoullian feat.
Numerous animals use tools that we don't even think about, dropping shells from on high.
I saw that. I was at the beach, and I said, "Oh, the seagull couldn't hold on to the shell, and it dropped. The drop shell. It went down, grabbed it, picked it up again, and did it again."
We don't know that what isn't common knowledge is that trees are discerning light. They, in effect, see. We don't know that the shellfish in the bottom of the ocean react to light and stimuli that we're totally unaware of. Shellfish.
Now, here's all I'm saying. All life on Earth, plant and animal life, and fungus and microbes, all have some DNA in common, which points to a single genesis here on Earth.
Right.
An alien that has no DNA or has DNA but no DNA in common with us should not look like anything here on Earth. That's all I'm trying to say.
Except it would have formed, it would have evolved wherever its environment is and made the most use of what worked and what didn't would fail.
Yeah, I agree.
So what works seems to be fairly common. Let me go further back than that.
Sure.
And plumb your abyssal.
I'll get home later and find out that abyssal means something else.
No,
and find out.
I looked it up to be sure I could
Okay.
use it.
Yeah.
Talk to me about how this started. If the Big Bang is a reality, or are we going to say, "Oh, the Big Bang, that's the same way the speed of light is looking hazy"? Scientists came up to me recently and said, "You're right. There's a question whether the speed of light is the ultimate defining factor, or can
The
light
speed of
be
light
faster?"
is not just a good idea, it's the law.
Now, at this moment in time. But tomorrow, they may find there's something faster than the speed of light. Abyssal.
You got people applauding you for that.
Abyssal.
Allow me to distinguish the statement that the speed of light is a universal law versus other things. Give me a moment. There was a day when people said, can't break the sound barrier. That they even have the very language that describes it implies it's unbreakable. At that same time, when people said that, we had rifle bullets moving faster than the speed of sound. The tip of a whip that has a cracking sound at the end, that crack sound is a mini sonic boom because it traveled faster than sound in that instant. So, if you were one of those people who said, we'll never travel faster than sound, or we'll never have heavier than air flight, meanwhile, birds are heavier than air, and last I checked, they can fly, except penguins, that can fly, then you're citing a vote of no confidence in the pace of science and technology.
No, you're
in our
proving
culture.
my point that at sound, they said there's nothing, you can't go faster than the speed of sound, and they did. I think
I'm saying they were idiots.
Right, so I'm saying the same thing applies to the speed of light.
No, except the speed of sound wasn't a fundamental part of the speed of sound as a limit did not form a fundamental part of everything else that we've come to understand about the universe.
Yes, but we don't understand the universe. And you and I had this kind of, I remember it vividly. I kept saying, there's dark energy and dark matter covering everything, and you're telling me that the scientific explanations are true, and you can't see this veil of energy that's 90% of the universe?
Okay, 95% of the universe. The 5% of the universe.
You don't know whether it's 95 or 90 or 85.
We know enough about the universe to quantify our ignorance about it. How do you like that?
That's pretty good.
That's damn good. The dark matter, a problem that's been with us for 90 years, is the longest unsolved problem in modern astrophysics. And it shouldn't even be called
the meaning of life hasn't been solved either.
I found quite a bit of meaning in life.
Right, quite a bit, but not the meaning of life.
Well, how do you know that I haven't found the meaning in life?
Because you haven't talked about it on your show.
I don't
if you knew it,
foist upon listeners.
You'd be broadcasting it. I have found the meaning of life. Listen to my podcast.
Because the meaning of life for me may be different than the meaning of life for others.
That's
almost certainly different.
Yeah.
But let me just say that the dark matter, that what we call dark matter, we really shouldn't call it anything because we don't know what it is, but we can measure it. And what it actually is like most of the gravity of the universe has no known origin. We call that dark matter. We should really call it dark gravity because that's literally what it is. Add to that this mysterious pressure in the vacuum of space, forcing an acceleration of the expansion of the universe. We don't know what's causing that either. So we call it dark matter and dark energy. That's 95% of the universe. The 5% of the universe we do understand, that's all our biology, chemistry, physics, engineering, and the speed of light.
And the speed of sound up to 50 years ago, when the Spitfire broke through the speed of sound, the speed of sound. What I'm saying to you. Wait a minute. What I'm saying to you is knowledge is fermenting. It's abyssal, which is unplumbed depths, and there's so much more to discover. I want you to talk to me about the explosion that was supposed to have created the universe. Do we think that is fact, or is that some guy's really vivid imagination?
So generally, we don't run around saying what is fact or not fact. We run around speaking.
You do that all the time.
No, I don't use the word fact.
It's truth. You say 95%. I say 90, you say 95.
Right,
correct me. That's a fact.
So they're objective truths about the world. These are the discoveries.
But sound was an objective truth.
No, it wasn't. It was because we already had things that move faster than sound.
But we didn't quote that.
Just because you didn't know how to make an airplane to do that yet didn't mean nature
was. But nobody said the tip of a whip is faster than the speed of sound until it was discovered it was faster than the speed of sound.
I'm saying people's thinking you can't travel faster than the speed of sound, part of that was fear, part of that was ignorance, part of that was people had no idea.
So that's what I'm saying about the speed of light and the origin of the universe.
Every single measurement ever made and every single observation ever conducted that involves the speed of light has given us the one limit of the speed of light in a vacuum.
But we don't know 95% of the rest of the knowledge.
Yes.
So?
Nor are we given reason to think that if we did, all of a sudden, the light would then travel faster than itself.
Scientific discernment, scientific questioning would say, hey, we don't know 95%. It's possible speed of light can be exceeded.
Okay, so let me pick you up on that. You ready?
Okay.
There's certain pockets of ignorance where...
There's a deep one right here.
There's certain pockets of ignorance, scientific ignorance, where we're not given any obvious reason to presume that once the answer is obtained, that it'll then answer this other thing over here.
Oh, geez, man, that's
it's not
scientific observation. You're what is the word? You're not believing it until you believe it. You got 95% that you don't know about. Surely that affects the 5% you do know about.
It can,
or it can't.
Yeah. So
right.
So. Where'd you get
I've got
this
you
guy
speechless. At long last, I've got him speechless.
So here's what can happen.
Yes.
Here's an example. Just to.
I'm ready.
You're ready. So, dark energy, what we call dark energy, is a mysterious pressure operating opposite what gravity wants it to do.
I got it.
Gravity pulls things
We're
together.
expanding. The universe is expanding.
And it's accelerating.
It should be contracting.
Accelerating in
Right.
its expansion. The day we fully understand I'm making this up right now, but
Well,
it's plausible.
So's everybody else.
No, so the day we understand what dark energy is, maybe it could one day be harnessed. If it can be harnessed one day, then we could make wormholes out of it, because wormholes, we can know how to do it on paper. You need something that acts in the opposite way of gravity to spread the fabric of space, whereas gravity collapses the fabric of space.
So
if you do that, step through the wormhole.
Listen, I was in Star Trek.
You are effectively traveling faster than light.
Oh, wait a minute. I was in Star Trek, and I know about this wormhole shit, okay? So what the hell is a wormhole? That's ridiculous. It's a figment of a science fiction's imagination, a wormhole. You're going to go through space and part time, and you can't go back into this whole thing about time. I've got to ask you about.
I don't want you to blow a gasket here on stage.
My gasket was blown 50 years ago.
So wormhole works with the equations of Einstein's relativity. We just can't make one because we don't have negative gravity stuff. If we
do have negative gravity, it's happening all the time.
Yes, we can't master it or control it. We can only measure its handiwork in the universe. It's part of this profound ignorance in which we're steeped.
I'm glad you said that.
If I can grab a piece of it and manipulate it, have the power to manipulate it, I would have the power to pry open a wormhole connecting any 2 points in the universe to each other simply by stepping through, effectively moving faster than the speed of light.
My point exactly. But we humans can't do that, right?
Not yet.
Well, but our atoms would explode. I mean, we would just...
No, it's just a hole in, and by the way, we had wormholes and antimatter. That's all our stuff first.
Right, antimatter.
Sci-fi people got to it later.
Talk to me about the big explosion. Talk to me.
The Big Bang.
The Big Bang. Talk to me about that.
All evidence we have ever gathered on the past, present, and future of the universe point to a single beginning where all matter, space, and time was in one place at the same time. And from there, it exploded. We have our theories of the universe and our observations of the universe track that all the way back to the beginning. You can ask, because I feel it.
We're hearing. No. We hear the waves. I understand. We're listening to the
So you can ask, what was around before the Big Bang? I have no idea.
Right. And why the Big Bang?
It is a frontier of research.
So what?
Well, I shouldn't say we have no idea. We have no evidence to support our ideas.
Well,
but there is an idea.
Give me an idea.
The multiverse.
The multiverse.
And we didn't just pull that out of our ether.
Did you just fart?
No. The multiverse is a feature of space-time that comes out once you combine the tenets of general relativity with that of quantum physics.
Everything you just said, I have no idea what
you know about this quantum physics. You surely heard of it. And then there's general relativity.
Okay, so I want to get to quantum.
So general relativity is large and quantum is small. The universe at the Big Bang was small. So all the universe, so quantum physics and general relativity had to make nice in the sandbox at the beginning because the large was small. And making nice in the sandbox, you crank the numbers, add the theories, and out of that comes a multiverse churning out universes.
Does it make sense, and I know you'll agree with me, that there are a variety of laws that govern the small and the large. It's got to be universal. It's got to be a unified theory of the whole scientific thing.
That's a philosophical bias that permeates us all.
But it's a reasonable.
I will not presuppose that. In the past, people have made similar kinds of proclamations. Look at Kepler. No, let's get Copernicus. Copernicus said, well, God made the universe, God is perfect, and mathematics is perfect. A circle is a perfect shape within mathematics, so if planets are orbiting the sun, they must be perfect circles. How could they be any other shape? They are another shape. Copernicus was layering onto the physical world a philosophical purity statement, for him deriving from deity, for you deriving from what it should make sense, and I will never approach the universe presupposing anything about it.
Well,
I want its data and the observations.
But then you should have talked. You should have talked to what's his name about a black hole. He presupposed a black hole and proved it by observation.
Yeah.
Well, that's science, isn't it?
Yeah.
Have a theory and then prove it through observation and information.
Right, but if you're driven by some philosophical elegance or purity or symmetry, maybe, but the universe is under no obligation to make sense to you.
No, the universe makes sense. We just don't understand it.
I would say those are the same statements. The universe would make sense to itself, but we have a certain sensibility that we have developed. You know, where did that come from? From the plains of the Serengeti, trying to not get eaten by a lion? We developed really good common sense about that.
Yeah,
but about infinity,
that's not what we're
quantum
talking
physics,
about. We're talking about a philosophical truth whereby we don't know how it all started,
right,
but it's got to have started, and nothing starts from nothing. So where are we with
I
that?
can't and will not presume that nothing starts from nothing.
It doesn't make sense for something to start from nothing.
And my point, the universe is under no obligation to make sense to you. I just make this up. I have, in fact, a colleague who has a hypothesis that the universe generates itself. So it's a full loop. So it removes the question of a beginning.
No, it removes the question conveniently, but it isn't a fact that something starts from nothing. It doesn't fit our logic that something starts from nothing. It has to start somewhere.
I will not presume the universe also has that rule.
Well, I mean, I'm not talking about the philosophy of God and creation. I'm not going there. I'm going from what seems to be logic. The logic of something starting from nothing makes no sense. I also don't understand a number of things that I want to get to as well, which is, can quantum, the most obvious, the thing that is most popular, that observation in quantum exists while you're observing it and ceases to exist when you stop observing it. Okay? That science fiction idea, until it was proven, is like incredible. Does that affect consciousness? Can we be conscious while we're conscious and unconscious when we don't think about it?
So there's a lot of borrowed phenomenon from quantum physics that has touched New Age thinking.
Are you accusing me of New Age thinking?
In that moment, yes. Only because people heard about the observer effect.
Yeah.
Where there's a configuration of atoms or molecules, and you say, I want to observe that. You go observe it, and the act of observing it changes its configuration so that you could not have known what it was doing when you were not looking at it.
Right.
Okay?
Superposition.
This sounds
Schroeder's
so
cat.
attractive to people who want to have our consciousness be a fundamental law in the universe.
Exactly.
That phenomenon that I just described has nothing to do with consciousness and everything to do with measurement.
No, but that's arrogant, man.
It's
How can you
true.
say, but it's arrogant. You don't know that to be true. Has nothing to do with. You can't say that. Might have nothing to do with it.
The power of science is that there's some things we can actually make
But why
statements
would
with that level of confidence. E equals MC squared. That works. I'm not hypothesizing it. It went on to paper. It went to measurement, observation, confirmation. It works. We're on to the next thing. Yes, physics can be arrogant about the stuff it figured out. Yes, and the trick is to be humble about the things we have yet to figure out. So, this observer effect is real, except it doesn't have anything to do with your conscious.
Well,
it has to do with the matter. I'll explain.
But wait a minute. Start with the abyssal, okay? The logic,
If you use that word one more time.
the depth of your knowledge. How about that?
Yes.
If you observe something, if something is in superposition, it's a multitude of positions, and you observe it and becomes a observable fact, it lacks the other position.
In the moment you made the observation.
Right.
Correct.
So why wouldn't that be conscious when you become conscious of whatever it is you're becoming conscious of?
Because you can set up a device to make the measurement, and it'll do exactly what it would have done had you made the measurement yourself.
Well, I'm
and
not
the device,
sure. What's his name was sitting under the tree, and it became.
Don't call him what's his name. It's Isaac Newton.
No, not Isaac.
Oh,
Newton.
okay. Who are you talking? Who else sat under a tree?
Brahma, the Buddha. Buddha sat underneath the tree.
Okay.
Remember Buddha?
I didn't know he sat under a tree.
He
This
sat
is
under
new
a
to me.
tree, and he became conscious.
Okay.
Now, I don't know what that means, but Buddhism is filled with imponderables, isn't it? I mean, we don't know, and the arrogance that we know is not there.
It's not. It's in science. It's not arrogance when it's objectively true. It's simply objectively true.
But that's our. The word is the German word is what we can observe. Our powers of observation are limited. Our eyes, our feeling, our sound.
That's why we invented science to bring methods and tools
those are
and apparatus that go well beyond your sight.
I understand that, but that goes only as far as we can observe that machine observing. We can only go as far as the Webb telescope observing, and it increases our observation.
I wouldn't have said only as far as the Webb telescope. I wouldn't have used the word only in that sentence. The Webb telescope, relative to our eyesight, it's not only as far as that telescope. This is designed to see the beginning of the universe and the formation of galaxies. Science, since the 1600s, the near simultaneous invention of the microscope and the telescope has transcended the limits of our physiological senses.
No, not transcended, extended.
I would say it would extend it if you were only limited, for example, to visible light. But it transcends it because now we can observe.
But we've superseded our observation of white light to red and blue. We've got machines that do it. Now we see red. We see X-rays.
Yes, and gamma rays, all of this.
Right.
Correct.
Those are machines that we, humans, invented, but that doesn't, there's no limit to that. We use machines.
I agree.
Right. Okay, great. Can we stop?
No. So we have these machines that not only extend our senses, but like I say, transcend them. We can measure things with machines that physiologically you could not measure at all. There's something called polarization, for example. It's a little obscure phenomenon that light can behave in this way. Your eyes can't see this. But phenomena in the universe polarizes light, and we have equipment that can make that measurement. You can't detect spectra with our eyes. We have special tools that'll do that.
But mankind invented those.
Yes, I agree. But what I'm saying is, you can't. Now that I have machines that can do it, this machine is sitting outside of your consciousness when it makes that measurement.
No, that machine is well within my consciousness because people like me, invented it and said, this is X-ray. We can see through the body. We can see through what was impenetrable. We can penetrate.
So what you want to be the case is that all of our machines collectively have created a meta consciousness of our species.
There you go. That's what I would have said had I had your abyssal intelligence.
So
consciousness. Talk to me about consciousness.
yeah, so I have very limited things to say about it. I happen to know, just from research in any field, that the more people write about a subject, the more it is evidence that we know nothing of that subject.
How can you say that with all the scientific documents that have been written that have been incorrect, but have suggested another avenue?
So I'm saying, if you look at this, if you ask the librarian, please take me to the shelf of books on gravity. They'll take you there. There's like 4 books on gravity.
No kidding.
Then you say, take me to the shelf of books on consciousness. There's shelf after shelf after shelf, and people are still writing books called Consciousness Explained or Our New Understanding of Consciousness. And hardly any of those books agree with one another.
What is the definition of consciousness?
You can start with Descartes. I think, therefore I am.
I am?
Yeah.
I don't understand that.
And that's fine. People are trying. They're struggling with it. But all I'm saying is the fact that people are still struggling with defining consciousness is evidence that we still don't understand what consciousness is.
And that same thing applies to dark matter and dark energy.
Correct. But it does not so much apply to gravity, because we can land a rover on Mars within 50 yards of a target after a spaceship goes for 10 months there.
I've asked you this question, and I've asked everybody whose information I admire this question. I don't understand space-time. I don't understand it. A photon of light leaves a galaxy 13.8 billion light years away. It travels 13.8 billion light years and reaches my retina. That's the space, 13.8 billion light years. The time it took is 13.8 billion years.
For you, not for the photon, but yes. The photon got to your eye instantly with no elapse of time.
Wait a minute. That I don't understand.
You didn't know about that. You didn't know about that. Okay.
Why do we say it took 13.8 and why do we say instantaneous?
Because if you are not the photon and you're sitting here on Earth and you timed it, it would take 13.8 billion years to reach
if
you.
you're not the photon.
If you're not the photon.
No,
if you're the photon.
But the photon is a photon. The light goes at whatever that 500 miles
as measured by you, yes.
We're back to the speed
let me get
of
back
light.
let me get back to space-time. So if I say to you, we understand space-time so intuitively that many of us think we don't understand it because it's so deep within us. So if I say, Bill, I'll meet you tomorrow morning at 9 o'clock. What's your next?
Where? Yeah.
I stated
Under the
time.
clock. Under the clock.
The time is insufficient to successfully meet up with you. And you knew this, hence you asked me. I say, Bill, I'll meet you tomorrow under the clock.
Yeah.
You're going to say, when?
Okay.
We know intuitively that your spatial coordinate cannot exist independent of a time coordinate if you're going to have the intersection of two people at the same time in the same place.
Okay, so the photon of light leaves the galaxy and travels 13 point. So I know that photon of light was generated 13.8 billion years ago.
Yes.
And has reached and as a wave or a particle, and I don't understand
Depends
that
how you
either.
measure it. Depends how you measure. It's a measurement phenomenon.
Right. I don't understand why it's either one or both. And I don't understand the split screen photon thing, which is photon seems to have a choice of going left or right. I don't understand that.
These are the fun mysteries of quantum physics, which defy rational interpretation other than the fact that we have equations that describe the phenomenon perfectly.
So I don't understand space-time, given those. It's over there. It's there. Galaxy's over there. It's going to take 13. That's time. Space. That's time, and then space is way over there. It's that galaxy way over there is the space between here and way over there, and the time it took is 13.8. What's the mystery?
Well, the time that it took is relative to your motion relative to that, to the photon.
Well, by a few years or whatever. But if I'm traveling if the Earth is traveling in the same direction, it's going to take a little longer for that photon pack to get to me, right?
Yeah. So Brian Greene, my colleague who's on this ship, a few sessions of these ago, answered brilliantly, how is it that time can shift just for being in motion?
I wanted to ask you that too. I mean, my heartbeat goes pa-pum, pa-pum. Why is it slowed down at the speed of light? It's still going pa-pum, pa-pum.
Yeah, no, it's at the speed of light, time basically stops.
But my
For you.
heartbeat continues. My blood, my calluses are getting softer.
So when Einstein proposes this, they're the Einstein naysayers, and then because he's a theorist, so Einstein doesn't do the experiment, other people do, experimentalists. Here's some interesting phenomenon. There is a particle that comes from space called a muon. It's a version of an electron. That's all you really need to know about it for this example. It comes from space. A muon is created in our upper atmosphere in a collision with particles from space. A muon has a lifetime that is shorter than the time it takes the muon to reach Earth's surface.
But I thought we saw muons in an oil bath.
Yes, we do.
Yeah.
Because if you measure the speed of the muon, it's going 95% the speed of light. So its natural decay time has been stretched because of the high speed with which we observe it to contain. So and this works perfectly.
But no, it doesn't work. I mean, to the lot. I mean, how do you? Let me just be practical.
Only syllables came out of your mouth in that last 15 seconds.
I'm in a spaceship and I'm going the speed of light and I'm making a tour of the universe and I come back and you're older and I'm not. My heart has beat the same number of times, but blood, of course, my telomeres have shortened that specific time. How is it I'm younger?
Because at that speed, relative to Earth, your clock was not ticking as fast.
But my telomeres have gotten shorter.
It got nothing to do with your telomeres. Everything about you would be aging more slowly. Your heart rate, your clock,
But
your
you mean my
thought
heart
process,
beats slower?
everything. But you don't know it because it's just your own time reference frame. If everything about you slows down, you don't know you're slowing down.
Well, then, but when you arrive back at Earth,
Then you can calculate how much you slowed down.
That is so illogical. That I know the atomic clocks lose time. I'm aware of that. I don't know why they.
And you're not immune from the time kept by atomic clocks.
Why does an atomic clock slow down?
I was going to explain.
Okay,
it
I'm
comes
ready.
out of Einstein's relativity. And Brian Greene
That's the answer to everything.
it's a good answer because it's a successful theory of the universe. But we know it has limits, by the way. The general theory of relativity explains the Big Bang and black holes, the expanding universe, and gravitational waves, and all of this. But it fails in the center of a black hole where there's a singularity. It fails at the very beginning of the Big Bang where there's a singularity.
How do we know that? How do we know that we lengthen as we enter a black hole? How do we know what's at the end of the black hole?
That's the tidal
That's
forces.
gravity. But we don't know what's at the end of the black hole.
In the middle, it's a singularity.
Well, what happens at the end of the black hole? What happens at the
that's-
other end of the hole?
That's where, in general relativity, it has been said that God divides by zero.
I don't want that word God lying around.
It's an expression.
Okay.
God divides by zero. The general relativity fails to account for nature at the singularity.
Well, that's huge.
The equations
isn't it?
blow up.
But that's huge. That's like it doesn't exist.
No, it just says we need a deeper understanding of the universe in which to embed.
Okay, so
general
we have a
relativity.
deeper understanding, and presumably it alters the original thesis.
No, it wouldn't necessarily do that. I'll tell you why.
No, not necessarily.
Let's go to
but
the other
you
person.
can add information.
Let's go back to the other person who sat under a tree, Isaac Newton. Okay? Isaac Newton came up with his laws of motion and laws of gravity. Towering achievements of the human intellect.
Did he actually transfer the apple falling to planets?
He sits there, watches the apple fall. It's in free fall to Earth. He sees the moon in the sky, orbiting the Earth, and he connects the two.
Does he know it orbits the Earth? Well, when did that concept?
We had orbits
occur?
since Kepler, so we're okay with orbits.
But Kepler came after.
No, Kepler predates Newton.
Really?
Kepler's a contemporary of Galileo, in fact.
Oh, I didn't know.
Yeah. So, and Newton died the same year Galileo was born.
No kidding.
Yeah, sort of.
Coincidentally?
Well,
or
it's
did-
sort of, well, technically, Newton was born in 1642. Galileo died in 1642.
That's abyssal right there.
No, so Newton was born Christmas Day, 1642. But that was on the Julian calendar. In Italy, of course, they're using the Gregorian calendar, where Galileo was, because it's the seat of Catholicism. And in England, they'd already schismed from King Henry VIII, and they're not going to do what the Catholics say, so they kept the Julian calendar. But when you reconcile the two calendars, which we've done in modern times, to the Gregorian calendar, which is the accurate one of the two, Newton's birthday lands in 1643, January 6th or something.
In any case, they were separated by death and birth.
Yeah, okay. So, getting back to this point, he sees these two phenomena and concludes they are the same phenomenon. That's an extraordinary leap of intellect.
It is. I mean, how does he do that?
How does he do that? He has a drawing of Earth and a little mountain on top, and he has a little cannon at the top of the Earth.
Oh, that cannon thing.
The cannon thing, yeah.
Cannon.
And the ball comes out, and it just drops down.
But he doesn't know it needs to go 18,000 miles an
No,
hour.
he doesn't have the speed for it yet, but he can calculate it with his theories. He's just conceptually analogizing a cannonball that just falls straight down out of the opening of the cannon, and now you give it some sideways speed, and it falls a little farther away, and at the faster you
Did he
send
write
it,
that out, or is that something
there's a
he said?
drawing of this,
Really?
of these arcs, and it keeps getting longer and longer and longer.
So he understood
the
it
cannonball is
intrinsically.
in continuous free fall to Earth.
Right.
And there's a speed where the free fall exactly matches the curvature of the Earth.
Does he know?
Oh my gosh.
Does he calculate the
Yes.
speed?
And so it comes back up, duck, and it'll keep going. And it will sustain and orbit all by itself. He figured out
Because
how
it's
to
been
get something
projected.
into orbit.
It's been projected out of the gravity of the Earth.
No, it's not out of the gravity. It is a sideways motion. That's why anytime you see any of the launches, the rocket goes up and is always going down range. It doesn't just keep going up.
Right.
Because it is at least half of that energy is to get the speed
Gotcha.
necessary.
How are we doing for time?
I don't know.
What? 2 minutes?
Oh,
We got 2 minutes
oh,
left.
okay. Oh, so my point was, here are all of Newton's laws, and then late 19th century, early 20th century, some things are failing with Newton's laws at their limits.
Like what?
Well, at high speeds, some things are not quite. And then Einstein comes along, 1905, new theory of motion, 1915, new theory of gravity. That extends our understanding beyond the realm over which Newton's laws applied. So I can tell you that Newton's laws are a part of a deeper understanding of how the universe works, brought to you by Einstein. If you take Einstein's equations, put in low mass and low gravity, they become Newton's equations. So I want to disavow you of the idea that when we have a working model of the universe and it fails at the edges and we embed it in something new, we don't discard what that was before.
Well, that was discarded.
He's
got a whole new theory.
We have someone in this room that went to the moon using only Newton's laws of gravity. They still apply where they apply. They all of a sudden
my understanding is they didn't. That the whole moon thing was happened on Earth.
Yeah, that's your understanding?
Listen, one more thing
Yeah.
before we have to go. Space-time. Will you try again? Tell me what the is space-time
I'm
is.
saying if you ever want to meet someone, you cannot do so without simultaneously providing a space and a time coordinate. We are fundamentally living, working, and
So
playing.
you mean space-time means the space and the time it takes.
And it's 4 dimensions, 3 spatial dimensions, It's
Up
implicit.
and down.
Yeah, the up, down, left, right, forward, back, and time. It is so fundamental to us. We can't even step out of that deep understanding and look at it and say, "Oh my gosh, it's 4 coordinates."
You
Now,
understand it, Chris?
here's all right. So here is my favorite thing to say about time,
Yes.
which does not apply.
Which we're out of.
We know we can go forward and backwards in all the spatial coordinates. We're not bound to one part in
backward in
space
time, I don't understand.
because we are prisoners of the present, forever transitioning between our inaccessible past and our unknowable future.
But the universe is expanding at a rate that we can measure. That's time.
Time is part of that
It's getting
too.
further and further away.
Time is part of that too.
When a plumber came into our house,
Plumber.
plumber.
We're going from space-time continuum
No.
to a plumber
and
in
he's
your
working
house.
on the toilet. I understand.
plumber working on a
I
toilet in
understand
your
the
house.
principles of what he's doing. He's got a rubber grommet there, and he's got the thing. I understand what he's doing. I don't understand what you're talking about, and it disturbs me. I think that's it for the.
So do we title this "Ways to Disturb William Shatner"?
Provide him with information he doesn't understand. What a beautiful thing. I love you.
And allow me to tell you.
I love you even more now.
No, let me tell you just real quick that by my measures, I don't claim full knowledge of the Comic-Con universe, but by my measure, when in the original Star Trek, and Gene Roddenberry and all these ideas introduced the warping of space and time so that you can travel vast distances without being bound by the limit of the speed of light.
That was the warping.
The warping, correct. That entire series had a respect for science that I've yet to see in any other franchise.
Because they
that
hired a lot of great science fiction writers
Yes.
who had a scientific background.
And they knew that there was a limit to the speed of light, so they didn't have you just have engines accelerate past it. They had to create another mechanism, and the warp drives allow you to warp the space in front of you, bring it closer, and you're basically traveling through the warps, where it reduces the effective distance, and then you unwarp space, and it's the full distance that it was before.
Yeah.
So you had people who understood when to respect the laws of physics and when to stretch them.
The episodes would be very boring if we had to wait for them to get to the next planet.
They'll be on next year.
It's how you cross the galaxy during the TV commercial.
What a beautiful thing.
That's why that works.
I got to engage with you more often.
And Bill, you are a national treasure. We love you, and we don't want to just live another 50 years for us, please.
I'll try and do that.
All right.
Warp speed.
Thank you.
Okay, I have 3 mics now. So in an exercise of space-time coordinates, and thanks again, Bill and Neil. Thank you. So, there will be a rematch. I think right now the wrestling match score it's 1 point each. So we're going to have a deciding match later on the ship. So coming up next, I think it's the tea time with Stephen Wilshire and live drawing. So who has the exact space-time coordinates? So it's deck 9 forward. No, aft. Deck 9 aft center. Those are the 3 time coordinates, space coordinates, and the time coordinate is now. Thank you. Thank you. Wow. Yeah. Thanks, Bill. You're a fierce moderator.